Hello, I am Abdul Raheem, an actor from IIT Bombay. In this video, we will be solving a previous year question from ordinary differential equations. This is the question paper of end semester examination that was conducted on 2021. And this video, we will be solving the 13th from this question paper. So here is the question. Consider the differential equation x square y double prime minus xy prime plus y equal to x square cos x on x positive. For any of its solutions y, value of half y double prime pi by 2 minus y double prime of pi is 1 plus 1 by pi, 1 minus 1 by pi, 1 by pi, and 1 minus 1 by square. Okay, so we have to find the general solution of the given differential equations, which is a non-homogeneous differential equation, and then evaluate y double prime at pi by 2 and y double prime at pi. So for that, we have to initially find what is y, then evaluate its second derivative and evaluate at particular points and evaluate the quantity that we have to find. Okay, so for that, I have to solve this differential equation, and this is a non-homogeneous differential equation. So the idea to solve non-homogeneous differential equation is find the general solution of homogeneous equation and a particular solution of the non-homogeneous equation. Then any general solution of the non-homogeneous equation is general solution of homogeneous equation plus a particular solution of non-homogeneous equation. So first of all, to find the general solution of given non-homogeneous equation, we need to completely solve its homogeneous part. Okay, so first task will be to solve the homogeneous part of this differential equation. So what is the homogeneous part of this differential equation? That is x square y double prime minus xy prime plus y equal to 0. This is actually a Cauchy-Euler equation. So the standard substitution will be y equal to x raised to m. Then you will get an auxiliary equation, which on solving you will get the values of m, which will help you figure out what the solutions, what the basis elements of its kernel will be. Okay, so let's try to find out the auxiliary equation. So because of this y double prime, a term m and m minus 1 will come. Okay, now I will put a minus sign. Then because of that y prime, I will get an extra term m. And since y does not have any coefficient, I will just get a plus 1 as the coefficient corresponding to that y term. So this will be the auxiliary equation of the given homogeneous equation. Okay, now I can simplify this. M square minus m plus 1 equal to 0. That is m square minus 2m plus 1 equal to 0, which means m minus 1 whole square equal to 0. So the possible values of m are 1 and 1. It's a repeated root. Okay, so in case of repeated root, how will we find the basis of the Cauchy-Euler equation? One will be x raised to m for sure, which is x raised to 1 or simply x. But we need to find one more. How will we do that? In the case of Cauchy-Euler, we will multiply by an extra log x term in order to find the second basis element. Okay, so this is the basis, which means a general solution of the homogeneous equation is of the form a constant c1 times x plus a constant c2 times x log x. This is the general solution of homogeneous part. Now we have to find a particular solution of non-homogeneous equation, that exact differential equation. I don't mean the exact from the ODE term. I just meant the exact equation. I mean the complete equation. Okay. Okay. So we have to find a particular solution, and it's a second order equation. So what are the different methods to find the solutions of second order equations? One is variation of parameters, and one is method of undetermined coefficients. But undetermined coefficients is usually used when we have the equation in standard form with the coefficients being just real numbers, not any functions of x. But here you can imagine, if I divide the entire equation by x square and convert into a standard, it will have functions of x as coefficients. So it is not natural to take the method of undetermined coefficients as the method to solve this. So a natural choice will be the only left thing, which is variation of parameters. Okay, so first of all, in order to apply the variation of parameters, I have to convert the given differential equation into standard form. So the given differential equation is actually this. Let me convert this into standard form. So dividing by x square on the entire equation, I will get y prime minus y prime divided by x, because x divided by x square will be 1 by x. Okay, plus y divided by x square, which is equal to cos x. So I found the standard form of this equation. Now what is variation of parameters? Variation of parameters gives an idea. What the idea is, any particular solution of this differential equation will be of the form c1x plus c2x log x. Now let me explain what I mean. Okay, here c1x plus c2x log x is actually just what I took from the solution of homogeneous equation. This c1x plus c2x log x is the actual solution of homogeneous equation. Now in this thing, what we will do in variation of parameters is we will simply replace this constant c1 and this constant c2 by two functions of x. They were earlier constant, but in variation of parameters we will replace them by two functions of x, which I call as v1 and v2. Okay, this is the technical of parameters. Now we will differentiate this equation twice and substitute in the equation. That's the general method, but we have a direct method and equation to directly find out what v1 will be and what v2 will be. Okay, so I will give you the equation. The equation for finding v1 will be integral minus y2 r of x divided by Wronskian of y1 y2, and the equation to find v2 is integral y1 r of x divided by Wronskian of y1, y2. You know what Wronskian is? Y1 means the first function with respect to order I consider the homogeneous equation. So what's the first solution of homogeneous equation that we found? It's actually x. So y1 is x. y2 means the second solution of homogeneous equation, which is x log x. Okay. And what is r of x? R of x is the term left in the right side. That only function of x that's left on the right side after convert this equation into standard form. So here that is simply cos x. Wronskian we can evaluate. We have y1 as x and y2 as x log x. So I can evaluate its Wronskian will be the Wronskian of y1 y2 equal to the determinant y, and here I will put y2, and below them I have to put their derivatives. So the derivative of x is simply 1, and what is the derivative of x log x? I will have to put product rule. So first function into derivative of second, which means x into derivative of log x 1 by x. So I will have x into 1 by x, that is 1, plus second function into means log x into derivative of first means simply 1. So I will have 1 plus log x. And you can evaluate this very easily. X into 1 plus x into log x minus 1 into x log x, which is simply x. So I got the Wronskian to be simply x. And now I have to substitute different things in order to evaluate what v1 is and what v2 is. Okay, so now my v1 is equal to integral minus y2. What was my y2? X log x into r of x. What was r of x? It was simply cos x divided by Wronskian, which is x. So I can get v1 by this integration. And what will be v2? v2 don't have any minus sign. So v2 equal to y2. y1 was simply x and r of x. y1 into r of x, which is cos x, divided by our Wronskian, which is x. So I do these integrations and get v1 and v2. So v1 equal to minus integral log x cos x and x gets cancelled, and here I will have v2 is equal to simply integral cos x, which is very trivial, that is sin x. Okay, now I have to do this integration for v1. v1 equal to integral minus, what is the integral of log x cos x? I can use that product rule in integral sense, right? It's known as Leibniz formula, right? So first function into integral of second, which is integral of cos x, that is sin x, minus integral of derivative of first, which means derivative of log x, that is 1 by x, into integral of second, into integral of second is sin x dx. Okay, so I got the v1 but not completely, and for completely evaluating this v1 I need to find the integral sin x by x, which you might be knowing is not a so trivial integral. It's not so easy to integrate this thing, and for us actually integrating that term is even needed. Okay, so I will simply leave it as it is because I don't have any other option left. There is no easy method to integrate that function. So I will have minus log x sin x, they are multiplying this minus on the outside, plus integral sin x by x dx. I will leave it as it is. Okay, and we have the v2 to be sin x. Now, what is a particular solution of the given differential equation? A particular solution of given differential equation will be of the form v1 y1 plus v2 y2, where y1 was x and y2 was x log x. So a particular equation, a particular solution of the non-homogeneous equation is v1 into y1, which is simply x. So I have to multiply x by this solution y1. So I will have minus x log x sin x plus x integral sin x by x dx. Okay, plus y2 into y2. Sorry, V2 into Y2. Okay, what is V2? Which is sin x, and Y2, which is x log x. Okay, now you can see the last term and the first term, minus x log x sin x and x sin x log x, get cancelled, and we got a particular solution of the given differential equation to be simply x integral sin x divided by x dx. So we have got a particular solution of the non-homogeneous equation and a general solution of homogeneous equation. Now the general solution for the given differential equation, by this I mean the general solution for non-homogeneous equation is general solution of homogeneous equation plus a particular solution of non-homogeneous equation. That means our general solution for the given equation will be c1x plus c2x log x plus what's the particular solution we got? That is x integral sin x divided by x dx. From where did I get these two terms? This is a general solution of homogeneous equation which I had already found out and kept here. Okay, this is the general solution of the homogeneous equation. Okay, now once I have found the general equation, this will be called as my y. This is my solution y. Okay, I need to find y double prime at pi by 2 and pi and do some calculation. So first, for that I'll just evaluate its second derivative. So first derivative will be y prime equal to c1 plus c2 into what will be the derivative of x log x. We have already found it out actually. It's actually 1 plus log x. So c2 into 1 log x, which I can write as c2 plus c2 log x. Right, this is same as c2 into 1 plus log x. Okay, fine. Now plus I have to differentiate this thing. Okay, this is actually product of two functions. I will consider that integral as a single function. Okay, so in order to differentiate this, I will use the product rule. So first function into derivative of second. What will be the derivative of integral sin x divided by x? Derivative of integral and integral of derivative will be simply that function itself. We know that they are just like inverse to each other, right? So I will have the derivative of integral sin x by x as simply sin x by x plus second function into means integral sin x divided by x dx into derivative of first, which is simply into 1, which I am not writing. Okay, so I have got my first derivative, and here this x and this x would get cancelled, and we will simply have a sin x there. Okay, now let me evaluate the second derivative. The derivative of c1 0, derivative of c2 0. I don't care about them. Now the derivative of c2 log x will be c2 by x plus the derivative of sin x will be simply cos x, and the derivative of that integral will be simply that function. That means we will have sin x by x. Okay, so this is our y prime, y double prime. Now what's the function, exact function which we have to evaluate? Half into y double prime of pi by 2 minus y double prime of y. Let me evaluate it that. Y half into y double prime of pi by 2 minus y double prime of pi. This is equal to, so half into, what is y double prime of pi by 2? Let me just substitute pi by 2 in place of x. So I will c2 divided by pi by 2. Pi by 2 in the denominator, right? So pi will remain in the denominator, but 2 will go to the numerator. So I have 2 c2 by pi plus cos of pi by 2, cos 90, which is sin 0, which is 0. Plus I will have sin pi by 2 by pi by 2. What is sin pi by 2? Sin pi by 2 is actually 1 divided by, I will have pi by 2 in the denominator. So pi will stay there and 2 will come to the numerator. Okay, that's it. Minus y double prime of pi. What's that? That will be c2 by pi plus cos pi. What is cos pi? It is minus 1. And we will have plus sin pi by pi. Sin pi is 0. So that's just plus 0. Okay. Now half into 2 c2 by pi will be simply c2 by pi plus half into 2 by pi will be actually 1 by pi. And we will have a minus c2 by pi and plus 1 from the second term. Okay. Now c2 by pi and c2 minus c2 by pi just get cancelled with each other, and we simply have 1 by pi plus 1. That is our option 1 is the correct answer. Okay. Thank you for watching the video. In the upcoming videos, we will be solving the remaining questions from the question paper. So stay tuned to the channel and join our Instagram and Telegram handles in order to get live updates. So bye.